Let's wait a little bit more. I suggest we start. Welcome to this session, Innovation Beyond the Technology and High-Tech Cross-Sectoral Applications. So I'm Christoph Schneidesch, Technical Director in Tractable Engineering in Belgium, and also a member of the board of the SNETP platform. And I will co-chair with Chrislyn. Please, could you introduce yourself?
Hi, hello, thank you. Good morning, everyone. My name is Chrislyn Sartakov. I am a PhD student from Estonia. I specialize on radiation dispersion modeling for emergency preparedness. And I am here today as a member of the young generation. So we will start the panel with all the panelists having a chance to introduce themselves with slides. And then we will move on to the questions. Our first question will be a general question to all the panelists, after which we will have 3 specified questions targeted for 2 panelists at a time. And we will end our session with questions from both the live audience and the Euratom4U app.
Okay, so as the title of the session is giving, so while nuclear has historically been driven by some innovation, advancements from non-nuclear industries are increasingly contributing to the nuclear sector. These cross-sectoral innovations enhance efficiency, safety, and the public perception and overall globally, while addressing key challenges and supporting nuclear energy's role in a sustainable energy future and nuclear science applications. So we have, thank you for the panelists again for being here. We have eminent experts in their own fields, and so they will share their experience in those specific topics. So we will start with Mr. Arne Larsson. So Arne Larsson is the head of strategy and partnerships within Cyclife Sweden AB, which is an EDF group.
Thank you for the kind introduction. To start with, I could say that Cyclife in Sweden, our operations started long back in time when we were a state-owned research facility. Then we were a commercial Swedish company, and today we are a proud member of the EDF group. And what we are doing, we are providing waste-lead decommissioning solutions. And what do? We are working with management of radioactive waste and also contaminated metals and other materials. For us, it's a big difference because a waste is a waste and the material is a potential asset. The commissioning of nuclear facilities. We also provide engineering services and software solutions related to the nuclear backend. What we aim for, one of the key aims for us is to transform nuclear liabilities to assets for the society by implementing treatment, clearance, and recycling of materials. This we have done for quite a few years, but there are further enhancements possible. Also to reduce the volume of waste for disposal as radioactive waste and to enhance the properties of the waste to be disposed of. We know that disposal volume is a scarce resource. But in addition to that, to provide innovative, safe, and cost-efficient decommissioning solutions for nuclear installations, and to combine all of this into one service. And I often get the question who we serve, and I would say that primarily we are serving customers throughout Europe. Currently in Sweden we have more than 15 customers from more than 15 European countries. And of course we are also serving within the EDF group. To give a little bit of flavor of the concepts we are doing when it comes to metals recycling, we are working from the project initiation to define the scope, to perform characterization, transportation, arrangement, the shipments, segregation, segmentation, decontamination, melting when applicable, clearance and recycling, and conditioning of the waste for the safe disposal at a later date. And of course, waste minimization is a key for us. And we have done a lot of projects over the years. We have been doing this for almost 40 years, and it's accelerating. To give an example, which I think is quite well known, that is the PWR steam generators, which is I would say the border between the reactor zone and the conventional zone in the PWR reactor. They have typically a weight in the range of 300 to 450 tons. With the current knowledge, we can recycle up to 80% of the metal back to the conventional industry. And we are aiming higher, so that is R&D ongoing on that. At the same time, more than 99% of the radioactivity is transferred to the residual waste, which is to be conditioned for disposal by the owner. And there is a massive volume reduction, and since the volume is the base for the disposal, we are at least in the order of 10 when it comes to volume reduction, some cases up to 40, 50. So that is, this is a little bit a short introduction to CycleLife. Thank you.
Thank you. And our second panelist is Professor Dr. Hamid Aid Abderrahim, who is the General Manager of Mirha.
Thank you for the organizer inviting me. I'll try. I was said that we have a bit more time. I said I can speak 2 days, but I will keep to my 2 minutes. Okay, so security of supply for a better tomorrow and sustainability of nuclear fuel cycle I wanted to address, because it was said, what are the link beyond technology to the society? So, first of all, why full recycling of nuclear fuel? Yesterday, I've heard in different sessions talking about what is circular economy, even that we haven't yet defined correctly. We are trying, etc. So everyone has a definition. But the reality we are looking at today, there is a growing need for clean energy. And finally, we started now to understand that nuclear energy will be part of it. But on the top of that, since now 2022 in Doha, then followed in Brussels in 2024 by the summit of Grossi and the Prime Minister of Belgium, saying that we want to triple nuclear energy by 2050. This means that we will need more and more fuel. And this is, you go to the mining, that's the biggest part in, impacting the environment. So we need for more resources. We need the optional use of the natural resources less and reduce then the nuclear waste also is part of it. And all this is pushing us to go to close the fuel cycle, and we should not continue to say this should be happening maybe in 2080 or 2100, because then we will exhaust the uranium we have. If you look to the Red Book of OECD, NEA, and IAEA, with present technology, just the park we have, we exhaust the uranium at affordable price after 186 years. And if we are tripling, then you can see that it will be faster. So we have to move to the fast reactor. Society aspect. Society today is telling that your nuclear energy, great. You are telling doesn't emit CO2, great. You mastered the safety, great, but they are all the time coming back with the nuclear waste. You don't have solution. Even we have already 2 countries that put geological disposal in operation. But all the countries are not having the luxury to have the space. We have countries densely populated, and it will be also a concern for us. So then we have to look to other things. So this fuel cycle, we have to look to the desire of the society. Prior to just coming with technology, I prefer sodium reactor, I prefer ADS, I prefer lead reactor, blah, blah, blah. This is just technology, and all of them, some have worked already, some are still to be demonstrated, etc. The driver is the society. Then it's nice to have technology, but it should be viable economically. So these are the 3 things that we have to satisfy. Then, I said it yesterday, I think, in one of the panels, for this idea of PNT closing the fuel cycle, we are working since 1950, when nuclear started. People, the first watts of electricity produced was with a fast reactor. But we never then continued that, and we were looking to that globally. And in 2005, thanks to all the European program we were doing in framework, FP4 we started, then FP5, 6, 7, Horizon 2020, then Horizon Europe. There are all-time projects for PNT. And that brings us to structure a strategy for going to industrialization. And what we said in 2005, it's already 20 years, that strategy, demonstration at pre-industrial scale of the building blocks of this technology of PNT. Advanced separation. We should not stop after Purex. The other element should be separated. We do that at lab scale, but we have to go to pre-industrial scale. Second, transmuters. Yes, we know that sodium can do, but very limited amounts of minor actinide if you want to take that with you. Plutonium, yeah, no problem. And we haven't done multi-recycling. We have to do it. And then, other aspect for that, you have then to fabricate fuel. Maybe you have to fabricate a different fuel, molten salt. Then, the transmuters that you can consider are actually for being capable to eat large quantities of minor actinide if you do solve the problem fast and rapidly. That's why we say the ADS can do the job better than a critical reactor for the minor actinide. I'm not talking about plutonium. But we can do it also in critical reactors, and the sodium, I said, is already demonstrated industrially, but the lead, it's still getting out of the ground. Last but not least, we should have that fuel containing large amount of minor actinide to be reprocessed, because in one pass, you can't burn all of the minor actinide. So there we have to go to other type of processing than the aqueous one. Maybe pyro will be doing the job. And last but not least, that was not in our strategy in Europe, but I am in charge of a task force at the level of OECD NEA, where we added the issue of manipulating, transporting the minor actinide fuels. And that we have added, thanks to the task force. We are finishing our report, by the way, for that, and intended for policymakers. About the strategy, the 4 building blocks of Europe, those are all the countries in the European Union working on these topics and different projects. And the last slide I have, what you have to take with you, if we want really to make this technology to fly and enter industrialization by 2050, there are these bricks that should be done in advance. We have to encourage the international collaboration and especially cross-cutting topics across the technologies, but also for the big systems that we have to build. Second, upgrade the existing lab scale separated facilities. Those who were in the main presentation, the main room, you have heard the director of GRC ETU. There we are already moving. This increase of the building, the MALAB, will be increased and we can reach the objective. Build the low TRL systems. This I'm talking about molten salt, ADS, or lead reactor. The sodium, we have the demonstration. We don't need to go to create a new kind of sodium. We are trusting that it can do the job. And then we have to develop this pilot reprocessing for recovering the minor actinide from irradiated fuel and fund the project for developing, acquiring new data for the society view on fully closing the fuel cycle. Yes, we want to do that. We technicians, we think we are the gods, we can do, and we don't care about what the society think. So we have to go to see what they think about that. And so therefore, I'm saying we have to invest also in that science. And we did for the geological disposal, great job conducted on that, but this on the fuel cycle closing and its values, etc., should be done. And we encourage all the project on compassing the advanced fuel logistics. And thank you very much.
Thank you. Our third speaker is Professor Dr. Christoph Huschen. Professor Huschen is chair of medical technical systems and acting head of Institute for Medical Technology, Faculty for Electrical Engineering and Information Technology, at Otto von Guericke University in Germany. Sorry, so.
Oh, you did a great job. Thanks, Christoph. Yeah, so first of all, Otto von Guericke is a guy with a vacuum, so maybe you can remember that with his experiment there. So it's always used in many of our used here. So if you look at what I'm chairing, what is my chair, medical systems technology. So the question is why I'm here, right? Because you hear a lot about nuclear technology, nuclear energy and stuff like that. But there are some things that are connected, and I will try to give you a little bit of that in terms of innovation. So this is my CV, and I don't read all of that, but I want to highlight a few things. So I worked beside some start of the career in the Physikalisch-Technische Bundesanstalt, so where I really learned about metrology, then in a radiology department directly at a university hospital. And I think that really gave me some very important insight, because it's giving you the task and the societal task, as you have just mentioned, I mean. And so this is something that where I really learned about the needs. And I think this is something that we have to focus on when we talk about education. Then I went on to the Helmholtz Center in Munich. I did there the Department of Medical Radiation Physics, and also for some time headed the dosimetry services there. And I was also the chair of the IAEA Secondary Dosimetry Lab. Then I came back to Otto von Guericke University in Magdeburg and took the chair of Medical Systems Technology there. And I would like to mention a few things. So that is also important. You need to have your scientific base when you want to do innovation. And that's why I mentioned the SPEAR conference here for physics of medical imaging. I was also a conference chair there. And then I also became a fellow of SPEAR. What is more important for our task here, and why I think I'm sitting here Michael, I think this is still correct, right? I was the founding chair of the EURAMED platform. You may have heard that we in Europe, we still think that we are ahead of many other areas in the world in terms of radiation protection and radiation protection research. And in 2012 to 2014, we started an endeavor to really put also the medical field of medical radiation protection into that topic, and we have this MENAS platform. So I became, as a member of EURAMED, the spokesperson of MENAS, which is the umbrella organization of all research organizations in Europe for radiation protection research. And I, as a kind of founding member of EURAMED, founding chair of EURAMED, and at that time head of the scientific committee, I had the honor to lead the endeavor within EURAMED Rock and Roll, a European project, to write a strategic research agenda and roadmap of medical applications. And so here you see these important parts as pictures. So this EURAMED Rock and Roll project was something very well. And the Commission published our roadmap on using ionizing radiation in medicine and improve the public health and the well-being of patients in 2024. So this is, I think, a very big step, and we are really grateful for that. And there we also focus a lot on innovation and how you can achieve innovations. So now I would like to go on a little bit, and here you see the MENAS logo as well. And now I would like to go on a little bit on what our chair is doing, just very briefly, and I won't read all of them. Obviously, so you see in the center, there are medical applications with ionizing radiation. This is a small, let me see, this small yellow block here. And we do a lot on radiation protection for medical applications, AI for biomedical applications, and that's something that I will maybe also talk a little bit later on when we talk about innovations, because I think this is one of the areas where we can really learn a lot about, from each other. We do a lot of translational things and personalized things, and now we try to put all these things together. Before I do that, I would like to mention a few of the projects that had been done within our group where we have been involved from EU, where we had EU funding. That's the MEDIRAT project. We have been, or we are involved strongly in pianoforte. I was able to chair the iViolin project. We have been involved in Sinfonia. We are part of a metrology project of the EU. So again, the cooperation is important, the interdisciplinarity. The Metrino project, then I already mentioned the EURAMED Rock and Roll. We lead the imprint project and are involved in the imagomics project, and we will now also have another one for AI image quality assessment, the so-called Fantasy project. And why am I showing you all that? Because what we try to do is we look for the bad side. So that's always what I try to claim if you start talking about innovation. We look at the bad side, and then we try to find questions. And from these questions, we go to the bench and try to develop various things. Like what you see here is organoids that we couple with nanoparticles. And then we try to look for the drug delivery. Or we do imaging then with that. We develop new molecular imaging tasks. And with that, we try to do predictive medicine, looking into diagnosis as well. And there we look, for example, for breast gas analysis. So you might ask, what is breast gas analysis has to do with radiation protection? Well, if you can decipher which patients or which people would potentially have lung cancer and which definitely not, then you do not need to do the screening in such a large extent as you would do today. And then finally, we use artificial intelligence for clinical decision support systems, but also for biokinetic modeling or for signal processing, and we can reduce the radiation dose in these cases by factors if we use, for example, interventional procedures, and do that, and we did that together with a project of the German federal government. Thank you very much. That's all from my side at this moment.
Thank you. Our next panelist is Toby Menzies. Toby is the secretary for the newly established NEMO and director of business development for Core Power.
Thanks, Kristlin. Thanks also to the organisers for inviting us to participate in the event today. I guess in these few minutes that we have available in this opening part, what I want to try and cover really is the following things. Firstly, a very quick overview of NEMO. What is it? Why has it been set up? And also importantly, what are the three main challenges in this space that NEMO is sort of setting out to solve? And that will link to that, and included in that will be a very brief look at each of NEMO's current working groups. So what is NEMO? NEMO is short for the Nuclear Energy Maritime Organization. And obviously where we intersect, I feel, with this panel, you'll no doubt anticipate, is that NEMO's cross-sectoral interest is with nuclear in the maritime sphere. NEMO is an industry association. It's a relatively new industry association, as Kristlin mentioned. It's only about 1 year old, and it's specifically concerned with standards and regulations around mobile nuclear energy solutions. So that means floating nuclear power plants, and then later on nuclear ships, nuclear-powered ships. There are other NGOs that exist in the domain specifically of nuclear materials transport, but NEMO is actually the only industry voice of mobile nuclear energy solutions. And NEMO's goal really is to bring these two industries together, nuclear and maritime, bring them together specifically in the regulatory domain, and to be the body that can help around how the gaps between existing standards and rules are bridged, and to be the subject matter expert group that can assist regulators in developing new sets of standards. NEMO is quite a broad church. Membership is derived from about 8 segments across both the maritime and the nuclear sectors. And we currently count shipyards, ship owners, classification societies, marine insurers and law firms amongst our membership, as well as a group of nuclear vendors and technology and project developers. But I think the key vision that NEMO members share is the creation of a future-oriented set of rules and standards that will allow for floating nuclear demonstration by 2030. So that's a bit about the what, if you like, but the second question really is why? Why has NEMO been set up? And that's really because apart from some experimental units from previous decades and some state-sponsored projects in Russia, floating nuclear hasn't really been done before in the commercial space in a meaningful way, at least. And that makes it pretty exciting. You know, we shouldn't be put off by the fact that the challenge is pretty difficult, because the opportunity that's out there is quite large. So there are 3 really main regulatory challenges, barriers, I guess, that exist in this area that NEMO has been set up to address. And in simple terms, there hasn't been a coherent attempt up to this point, or really no common incentive, we could say, to try and tackle these challenges. And what you'll notice is that it's no coincidence that we've identified these 3 main challenges, and there happen to be 3 working groups currently within NEMO, and each of them is really aimed at grappling 1, 2, and 3 as we've set out here. So I'll take a quick look at these individual working groups next. So these really are the engine room of the organization. Each one, as I mentioned, has been set up to assist in one of those 3 key areas from the previous slide. The first group is called the Nautilus Working Group. It's looking purely at how shipping's top regulator, which is the International Maritime Organization, is hopefully updating its old nuclear rules and standards. They do exist. They're contained in the Nuclear Code for Merchant Ships, which sits underneath Chapter 8 of SOLAS. Now, this needs to be revised and updated because it hasn't been considered or looked at since it was first ratified in 1981. The second group is kind of considering things in reverse, if you like. It's how the overall nuclear regulator, the IAEA, is considering maritime deployment of nuclear technologies. And there is something developing within the IAEA, and I apologize in advance for more acronyms. Shipping and nuclear, both pretty acronym heavy. But there is something called the ATLAS initiative developing in the IAEA. ATLAS stands for Atomic Technologies Licensed for Applications at Sea. And with that initiative developing, there's clearly much for that working group to get aligned with and to assist on. And then more recently, towards the end of last year, a third working group was stood up, which is called the ANORAX working group. And that looks at the equally important challenge of insurability in this space and liability regimes. And you can see at the bottom there that future working groups may also be engendered, which kind of encompass other parts of what is quite a complicated puzzle as well. But that's it for my brief introduction, so thank you very much, and I'll hand over.
Thank you. Our next panelist is Mr. Michael Hübel. He is in DG Energy, Deputy Director and Head of Unit, Radiation Protection and Nuclear Safety, and he's also Director General of Euratom Supply.
Thank you very much for the kind introduction. It's only one of the two, actually. I'm Director General of the Euratom Supply Agency, and indeed I used to be in charge of nuclear safety and radiation protection previously in DG Energy in the European Commission, and before that I worked in different fields, particularly around health issues. So Christoph and I go back a certain time in looking at what we call on the nuclear fields, the medical applications, what we call in medicine, nuclear medicine and radiology. So it's a big pleasure to be here. I want to use this introduction just to say a few words about the Euratom Supply Agency. You notice there are two European agencies with the acronym ESA on the podium today. The Space Agency is bigger, we're older, but we do different things, but I mean, we get confused quite a bit. I mean, I do receive a lot of mail for the Director General of the Space Agency. It's very interesting to have an insight into their work, but seriously. The Euratom Supply Agency, a little known part of the Euratom family, if you like, has already been established by the Euratom Treaty itself. It's the only European agency established by a founding treaty. And our tasks, broadly speaking, is really to ensure the supply of nuclear material, nuclear services for the Euratom community, the European Union, if you like. And in that, of course, we cover not just power uses, mostly power uses, obviously, but also non-power uses and other areas where nuclear material is needed. When the treaty was signed, the idea was that there would be something of a common supply policy in the sense that ESA would be larger than the other ESA and would actually be in charge of buying itself all the nuclear material on the market. This, for many, many years, this has never happened. But what we still do is we have what is called the exclusive right to conclude contracts for nuclear materials. So basically all contracts for nuclear material are countersigned, are by the agency, and we also receive for acknowledgement all contracts for services. Now, this is not just a bureaucratic exercise, but the idea behind the exercise is that there is at all times a clear overview of the security of supply landscape for Europe within all the sort of political, legal and other circumstances we are working in. And in that sense, that information we have feeds into our second important function, which is the monitoring of the European nuclear market. And the most important manifestation of that work are the annual reports we publish. This is the 2023 one. The 2024 report should come out next month. And it really gives an overview, and probably the best overview, of the security of supply situation across the European Union, and of course, it gives information on what we do as an agency in our different working areas. One thing we do is that we do provide recommendations for security of supply, and as we talk about transferability in this session, maybe this is something later on in the session we can come back to what these recommendations look like. And we have a special role on the security of supply of medical radioisotopes. So we, together with industry partners and member states, we operate an observatory on medical radioisotopes, and we also play a role in a Commission initiative called SAMIRA, which is meant to improve the situation also for stable isotopes, which are needed in the medical field. So that should be enough, I think, to introduce our work, and I look forward to the session. Thank you.
And now, our last panelist is Jamila Mansouri. She is the head of Propulsion, Aerothermodynamics, and Flight Vehicles Engineering Division in European Space Agency.
So thank you very much for giving me the honor to be present here. And thank you, Michael. It's true that it seems that we are working in the same place. It's not the case, and to be honest, I have. We could try because you will be more helpful than me in the new mission I have now, as it is to get closer the space to the nuclear world. And as well, as we are indeed quite big in our agency, sometimes it's better to be smaller in order to be more effective. So I should say it. So anyway, so I don't know if you know already, Isa, I will first introduce myself and give you a few words about the European Space Agency. Myself, in fact, I started my career, I have the, you will see the age I have because I have the same age as the European Space Agency because it's not so young. Yes, it was created in 1975. So let's say just 20 years, about 20 years after Euratom. And the mission of I had myself over my past experience were initially focused on space transportation, which is one of the directorate of ESA. And at that time, I was in the industry as I was contributing to the heavy launchers. I started my career on a launcher named Ariane 5, for those who don't know this launcher. It has retired last year, and it was capable to embark about 11 tons of payloads. And I, let's say, continue on Ariane 6 before I moved to ESA. I was also a part of the operating team in Kourou, so I had the chance to myself contribute to the operations, and I can say that operation is very sensitive. We didn't have the chance to send any nuclear component in space because, unfortunately, there is a lot to do there, and I will explain you later on. And after my experience in the industry, since 15 years, I am now in ESA working from system to propulsion. And in propulsion, there is a lot to do. It's not only launching, it's also spacecraft mobility, it's rover mobility or landing mobility. And also, as there are connections between propulsion and power, now it's also surface habitat energy necessary to extend the limit and move towards more deep space and maybe establish one day on the surface of other planets some habitat. So my new mission now is exactly to develop a roadmap and to implement it for nuclear power and propulsion for the transfer in space and for surface habitat. I will only concentrate on the early stage because my mission is limited to technologies until TRL6. And then I hope there will be some program to who I will be able to hand over and in a joint manner because we need all the stakeholders. So let me just move, sorry, I will not show this one, but I think Can you move to the next presentation, please? So let me just give you a few words about European Space Agency. It's 11 directorates. We are about 3,000 people. And the 11 directorates, they are enabling directorates. So I mentioned space transportation because we need a vehicle to bring application in space. We need technology, so I am now part of the technology directorate. And there are application directorate like telecommunication, navigation, Earth observation. And the two one, the nuclear could be very useful, are for exploration and science. The mission of ESA is really for everyone. It is the first and ever mission, when it was created in '75, was to develop peaceful exploration and use of space for the benefit of everyone of ESA member state. And the difference between European Space Agency and the other ESA, let's say, is that we are a sister of the European Commission. We implement for the European Commission, but not only. We have 23 member states, and among them there is non-European countries like Norway, Switzerland, and UK. So you will understand that we work quite in close relationship with UK on the topic of nuclear, notably on RSU and RTG. And we would like to continue to work on other topics together with other countries. So why space, nuclear power and propulsion? As I already mentioned it, it's to push the limit, in particular for science. We are limited by the solar panel, by the classical chemical propulsion, let's say, or electric propulsion, which prevent us to go quicker and deeper in the science exploration. So in order to be able to help all the astronomers to continue to explore our universe, it was highlighted the lack of ability to use sometimes the sun power, the power generated by the sun, and alternative sources were considered as welcome. And also, it's not a matter only for energy, it's also a matter of heat source to maintain in a good condition the equipment, the instrument of the science. The second interest is, of course, transfer to moon, transfer to space, to Mars, take quite a long time. It takes about 1.5 years to reach Mars with the classical, let's say, vehicles and transfer. And we are obliged also to wait every 2 years before launching because we try to save this vehicle energy spending. So with nuclear, we will have more opportunity to launch, and it will reduce the travel by at least 1 to 2/3, so maybe less than 6 months to Mars. Moreover, our objective is also indeed to continue to push the limit of the human exploration. It has always been the case. You remember the Conquistador. So we would like to do the same, but further. Not sure that we will go and do the round of the universe, but at least we will go at a certain distance and have back our human astronauts, let's say, and not only robots to Earth and to share their experience. So exploration for human spaceflight is really essential. I would like just to quote the ENS, where it was clear that the development of European nuclear space capabilities for power and propulsion is really an endeavor, and we need to build a robust, resilient, safe capability for Europe. I should say that's all for the introduction.
Thank you very much. So now after this introduction, please, I remind you that you can use the app to put some questions on the application. Now we will move to, let's say, the structured discussion part. basically, let's say we prepared one question that will be asked similarly to all the panelists. And so the question is, of course, related to the topic of the session. And the question is, what are some of the most exciting interdisciplinary collaborations and breakthroughs that you foresee happening in the next decades? So, Arnie, if you can, let's say, just elaborate on your thoughts about this.
Oh, thank you for the question. As a back-end guy, so to say, within my professional, I would say that circularity and the zero waste initiatives are something that will have to come. We will have to learn from nature, because in nature there is no waste. We need to learn. There is a lot of learnings possible with it. And we need to change our mindset to see what can we take, what could be beneficial from the different, what we call the waste fractions today. And I think it's important also to point out that this is not just related to nuclear, because that's what you hear in the discussion from time to time. Because when you go to the wind power, the solar power, etc., they are facing the same problem. And when I hear and I've been part of discussions when it comes to solar, I say, it's too early, it's decades away before we need to manage the waste. But then it's too late. You have to handle this upfront. Thank you.
So, Christophe?
Okay, thank you. Yeah, I think from my point of view, first thing is obviously that the interdisciplinarity will really push innovation, and this will come to various things, like we can do a lot of biological enforced medicine, but we can also transfer that to other topics, right? So wherever we put together really a task, a question, and then the approach of various disciplines, this will make innovation. And that's what we feel a lot, and that we see on a daily basis, basically in medicine. There's a lot of things, so more personalized medicine will be the top priority, I think. And this will all be based in our field also using new technologies like AI, right? And there I would like to also make a certain plea, because we can look together on certain topics that we have to address when we are using AI. And I think the nuclear energy field is there very similar to what we see in medicine. We have to be very careful about the data. The outcome has to be secure. So ensuring that AI procedures work and not just provide results. They will always provide results. But the question is that true? And that strongly depends on data and measurement technologies. And we have to put that forward. And if we can do that, then it will really give us breakthroughs in many, many things, including the personalized medicine that I mentioned before. Thank you.
So if I may interpret what you said, the interoperability in the methodologies would perhaps make a bridge between, let's say, the medicine field and the usual, the power related applications.
In many aspects, yes. I mean, we talked yesterday about waste management, where this will come up, and where it will come up from the nuclear field, but also from the medical field, right? Michael mentioned medical isotope supply. This is another thing where we can talk about what, and I know about projects that are already running in this direction, but also the way on how we deal data, how we ensure quality. These are things where we can really work together and make innovation vivid.
Yeah. Does it mean that you could foresee that you have some kind of a common standardization on the way that the problem is defined or just dealt with?
Yeah, actually, when I was in the AI session the other day, I thought maybe we should start up closer collaborations to enforce the collaborations and look on how we approach the topics. And I think that could be a very important aspect.
Great. Thank you very much, Christophe. Michael, can you share some thoughts about this, let's say, cross-sectoral approach and
well, I could also say medicine, and I think medicine is the obvious example where there is a lot of a potential for further innovation and cooperation, and it is clear that if we move towards circularity, as was mentioned, this is also important, but maybe I would like to answer the question slightly differently. Because I think the challenge and maybe also the condition for the nuclear sector to really sort of reap the benefits of this huge amount of innovation which is out there is to really, much more than before, to be open. And I think to be open to that, to be placing itself in the middle of society and having this debate with society about where nuclear fits. And I think, Hamid, you were mentioning the societal challenges right at the beginning of your introduction. I think that is very much the precondition, because obviously the nuclear sector has a lot to give, a lot to bring. Also, as Christoph said, the focus on safety, the focus on security, the focus on a cultural approach around that. And other fields have similar approaches, bring them together. I remember when I ran nuclear safety, we worked on emergency preparedness and response with people who were preparing for chemical accidents, with people who were preparing for big disasters in other areas. And if you look at the response, for example, to the COVID pandemic, the way the nuclear sector has shown resilience on the regulatory side and also on the operational side has been quite remarkable. There are many learning points and there are many points for bringing things together. And it is indeed true, I think, that these big innovations around AI, around digitalization and so on, that they provide enormous opportunities in this respect. And we have to, a little bit as the nuclear sector, leave the comfort zone. I mean, it's great to say my agency was created by the Euratom Treaty. All our legal framework goes back a long time in the nuclear world, in radiation protection and nuclear safety, and it's a good legal framework. But is it proof? Is it ready for this kind of innovation? Is it ready for this kind of push which will be coming? So these would be questions which maybe are precursors and preconditions for the question of the kinds of transformations we will be seeing.
So it means that breakthroughs are expected not on the scientific part, but also on the other types of areas like, let's say, the public acceptance, the perceptions, and so on. Those should be also considered as breakthrough to be needed in the future, right?
Well, if not as breakthroughs, but as preconditions for taking advantage of these developments. So, I mean, I share what was said about, but I just don't want to repeat either these sort of big areas where obviously there are big potentials for transformation, innovation in the nuclear sector.
Great, thank you. Hamid?
Two aspects. Your question was saying how we can trigger actually innovation and accelerate. I think two aspects. The triggering is because you create the desire within the society, and therefore I said we have to involve the society in when we are innovating. It's not hidden, it's not just behind the curtain and we come with a fantastic thing for you, don't worry. And I think we can learn what are really the expectations they have, and they understand what we wanted to do, they influence us, and we then take those considerations in our innovation. That's one thing. The second thing, you can get great ideas, you can get consensus or, let's say, support of the population, etc. At the end, if there is no money to do the job, then you are in trouble. Because, I would say, the brilliant ideas you have, if you can't turn them into projects, then you are going to miss the chance. And therefore, I think we have in all those projects that we are conducting or innovations we are conducting at European level to also in the field of nuclear understand that we need something which is a sort of basis for the development of all those nuclear applications or technologies, where you have a sort of nurturing, let's say, environment, because it's a concern for all the citizens of Europe, and that I will disappoint maybe the people. It will need public money. So therefore, the interest of the society, they accept that part of their, let's say, tax they are paying is serving to create the innovation, and not for just the sake that we make some companies rich. That also should be once understood by either both the companies and also the citizen. We need companies that turn this innovation into products, but there is a sort of social responsibility for the companies to pay back, because they initiated all their business thanks to public money. And I think this is the concept that we have really to work out as a society, and then all the actors then should be trying to reach that objective. It's not a bad thing that we have companies that are performing. It's not a bad thing that we have companies that can turn a business with profit, but it is bad that we have companies that are just doing profit for profit. And that is what we have to bring as a new paradigm in our development, especially as a society which values, let's say, the welfare of everyone, etc. It should not stay only slogans. It should be turned in actions, and then these public money. Yesterday in one panel, there was a gentleman speaking why the startups of fusion will get rapidly to develop their small fusion reactors when the fission people are doubting about this story, because we have a big project that a lot of people criticize, ITER, which is costing, people think it costs a lot of money. Yes, it cost 15 billion or even more. But when you look all the supply chain they created around, they will not suffer for supply chain. We are asked to build the reactors. We don't have no one to provide us what we need, because there is no public money maintaining this supply chain alive. And so I think these are the paradigm that at the level of Euratom and at the level of the countries and the governments we have to think. If we are serious to say nuclear energy will be part of the future for different applications on the top of that, it's time to revisit the way we were doing in the past. Thank you.
Thank you very much. So Toby, for the maritime sector, what are, let's say, the interdisciplinary, let's say, breakthrough or co-working parties that you would like to see?
Sure, thanks, Christophe. I mean, there are many. I think if we take some of the collaborations first, there are quite a few going on now, whereas I think nuclear and maritime was at the periphery some years ago. It's steadily moving more into center stage now. I think there was a time, not that long ago, where it was a bit of a joke topic, actually. People would think this will never happen. And it is still challenging, as I mentioned, but it is coming closer to center stage, and I think it's now no longer really about the if, it's more about the how. And obviously the collaborations are a key part of that. I think the most important collaboration by some distance is going to be collaboration between the manufacturers of advanced reactor technology and world-class shipyards, and forming that as an integration hub whereby for the first time we can start to build entire power plants as a mass-produced product. That's something that I think the nuclear industry has been hoping to move towards for some time, get away from constant first-of-a-kinds and get down that cost curve towards nth-of-a-kind. Building these systems in top-class shipyards will enable that. And then furthermore, they can then be operated as a fleet approach in a closed ecosystem, but we can probably talk a bit more about that later. But that's one of the main collaborations that I see. In terms of, so it's a collaboration and a breakthrough in some ways, because I think that will help achieve some of the nuclear industry's goals and the maritime sector's goals, because that's an industry that's been looking for a zero-emission solution. It hasn't really been able to find one yet. Really, the maritime sector is at a little bit of a fork in the road. Much of the sector is evaluating low-carbon synthetic fuels, which, the emissions footprint will change, but it's far from optimal. It's kind of compliance, but at the cost of competitiveness. And nuclear propulsion offers a very compelling alternative to that, but it has to be done in the right way. So I guess an important breakthrough in this space is going to be the development of marine-appropriate reactor technology. Pressurized water reactors, the nuclear that we've grown up with, is not suitable for use in the commercial space, and that's because it just can't be insured. These reactors have an emergency planning zone around them, as you well know. Bringing that on a mobile unit into a port creates insurmountable challenges for the operator. So something that Hamid touched on earlier, actually, NEMO's members encompass technology development across the area of molten salt reactors, high-temperature gas reactors, heat pipe reactors. And they are all at different TRL levels. There's nothing out there on the water yet that you can point to and say this is a proven concept. And they're all at different stages on their licensing path as well. So it will be various small breakthroughs when they get to that readiness level. And then I suppose, not a breakthrough, but most of those advanced reactor developers are seeking HALEU as their fuel source for those machines. And again, we don't need technological breakthrough to manufacture HALEU. We know very well how to do that. But the breakthrough will be in government de-risking the production of it and balancing that tension between the supply and demand that we currently have, kind of diffusing the chicken and egg situation that kind of exists currently. And then I guess finally another one could be collaboration between maritime and nuclear insurance providers, because there needs to be created a future product for this new market that's kind of appropriate and affordable for the sector. Interesting that Michael touched on collaboration with the chemical industry, right? You can see, and this relates a little bit to insurance, because you can see that where some port authorities are considering allowing vessels that are using ammonia as a bunker fuel in their port. This is something that carries quite a significant risk profile. And I think a lot of the work in the future will be around educating the insurance community. The risk profile for new nuclear maritime is quite different. And nuclear is not this kind of problematic child that's been on the top shelf that you can't touch for so long. So that's my perspective on it.
Thank you. I see there is still a long way to go. So, Jamila, with your specific view from space, if I can say so, what are your specific recommendations?
So I will pick a little bit of little things of my colleague here with my point of view. But the first point, I would say, is the collective will. We have 23 member states. Some of them are a little bit reluctant to include nuclear in the space, because space is already, let's say, very sensitive. And it's not easy already to convince sometimes our member states to move on some out of our comfort zone, let's say. So our objective is to do so, to get this collective will, is to rely to our colleagues who have already succeeded somewhere where we have not yet done the endeavor, and to try to include the space on top of the ground application. And maritime is a good example where we can rely on the background and the experience. On top of the collective will, I agree, money is essential. So once the people are ready, in the sense not breaking because of the risks associated, the risk to the humanity, let's say, and to the space, because bringing nuclear fuel in the space can be very dangerous, and in particular when we put that on top of a launcher that can explode at any time. So I can tell you there are a lot of steps to withstand. Then it's the cost associated to that. And it's even more expensive that we are very demanding in space in terms of energy. I will show that. Can I ask the technician to show up again the slide I presented, the last one? I have just one slide to complement my answer, if you mind. Thank you. And I would like to say that it's a little bit difficult to put the constraint to the colleague when I go to the nuclear sector and ask them. I need a very small. So I'm now using the interesting breakthrough, very small, meaning micro-reactor, because I cannot embark that. I'm limited in performance. I told you before, 11 tons today in Europe, maybe 12 soon, and the next step is to go further. This is in geo orbit, but we can go up to 20 if it is in LEO orbit, and then we need to transfer that. Would you mind to show up the last presentation on the screen, please? So that's the reason why, for us, microreactor is a breakthrough, because then we will be able to let's say, to develop nuclear in space. Thank you. So I did already presented that. So microreactor is for us the breakthrough. So I put an example here. I don't know if there are people from Rolls-Royce in this room, because they are pushing. UK is pushing. I mentioned it. UK is part of ESA member state. UK is pushing, and they are pushing for microreactor based on fission. And we are ready to listen to any other stakeholders who are willing to push also microreactor and to accelerate that kind of technology because of the limits of the mass, because of the compactness, because we need to embark. So in terms of interdisciplinary, let's start from the technical concept. Of course, it's already itself an interdisciplinary element where we need a lot of skills. We need to develop these skills. ESA is not yet, let's say, even if we are big, we still need other skills. So maybe we could share there. That's the advantage with my colleague. So in particular, I will address some points that concern anyone here, but certainly in the forum here. About fuel, about material and process, about power conversion, thermohydraulics, and also you mentioned IA, so health monitoring plus artificial intelligence will be essential. So beyond the technical element, then I go to Arne. I'm completely interested in what you are doing in EDF. It's essential that when we go through the development of such solution, that we need to have, from the beginning, an eco-design perspective. We don't want to pollute or to create a lot of waste in the space, and it will be not the same to recycle because we are not established in outer space permanently yet. So we need to think about how we deal with waste management. First, waste management developed on ground, but then in space. Another interdisciplinary is the logistic, because we need to transport from ground to the launch port, to the spaceport, what we call, and then we need to fly it with, so logistic is important. And additionally, regulatory framework, of course. In particular, the issue we have is that from a country to another, they are not the same regulatory framework. So I hope that my colleague has already, let's say, prepared the ground for that, because we will have to take your regulatory framework and to include the space aspect and make sure that we have an harmonized approach, because if we need to transport this kind of thing that is produced in UK or in, I don't know, in France or whatever, to another country, because we need to integrate it and then to launch from another country, that will be very hard for us. And last but not least, of course, safety, it's always coming on top, because when we move to a country to another, we don't want to have barrier. There is a lot of administrative tasks, so it's super important. So those are more or less the list of interdisciplinary. I may have forgotten others, but as you can see, a big breakthrough for us is the microreactor to pave the way to propulsion and to surface habitat. And we need a lot of skills to make it happen, and a collective will and a lot of money.
Great.
Yeah, I will do a crowdfunding if you want.
Thank you very much. Now I've checked.
Christophe?
Yes.
May I give some hope? Because sometimes we hear too much problems. Transporting tiny quantity of uranium that you will be having there, honestly, we should not over-exaggerate the problem. We are transporting tons of fuel from the fuel production plant to the 400 reactors of the world. And in Europe, there are 140 reactors. So there are people dealing with that. We have just to sit with the right experts, and that it's not a big issue, the transport. I can guarantee you the grams that we will have in there. But I think it is a new, for sure, we have to look at the specificity of that transport, etc. But we should not think that it is impossible. Otherwise, you will not dare to innovate. We are transporting fuel to our nuclear power plants in large quantities.
I'm not saying it's impossible, I'm just pushing the limits everywhere. So I'm just saying we have some breaks, some reluctant people, and can be even at the bottom, not necessarily at the top level. And we are delayed, and the idea is, again, when I say collective, is to bring awareness and to have a real, let's say, good communication to each level, so that we can do it on a good path, on a good velocity for that. But it's mainly the breaks that I fear.
Well, I know by experience, habit, that sometimes transporting material, some radioactive materials across countries, it's doable. It's doable. I do agree with you, but you have to be prepared well on time. Just to make
I agree.
happens.
I agree. It's not, I would say, just like you are transporting your potatoes, that I know. But we are doing that, I say, with tons. We are doing that with tons. There are rules, sure. You have to respect them, that's for sure. But I mean, we should not all time telling in nuclear nothing is possible. That's what I am trying to make. We are doing that.
I do agree. I do agree.
I should, because otherwise I would not hear.
Well, I've checked on the app. There are no questions which are, let's say, listed. So perhaps before moving to, let's say, the specific question time, are there any audience, some hot burning questions that you won't like to miss before the end of the session? I don't know if there is a mic.
I steal the presenter mic. Thanks a lot, Christophe. And I'm a bit surprised because I input a question in the chat, so it must be somewhere. Anyway, so my question goes to Jamila. You said basically there are people that are reluctant to bring nuclear into space. My question is quite basic in the end. In the discussions that we have had over the past days at the conference, it really appears that basically nuclear is now recognized for terrestrial and energy applications as, let's say, something that cannot be avoided. And pretty sure that not only cannot be avoided, but for many of us is praised as a very valuable source of energy. Now, my question, basic question is it not the same, as far as I understand, from discussions that can be occurring between ESA and some of the vendors and technology providers? Is it not the same with long-range missions that are envisioned to be done, where, as you said, those missions will be quite distant from the sun and thus lacking energy sources? So is it not the same that nuclear is just the sole solution that exists to supply those long missions with the required energy? Just a very candid question in the end.
So in fact, today we are doing a very deep space mission. We have launched recently James Webb, and we are continuing. We are targeting much further because there is Enceladus. We try to go to Saturn. So we have done Cassini-Huygens a long time ago. The difference is that it's the time, the duration of test mission. To reach the target can take very long. And also, it's a matter, we have done already some study on what we call the thrust-to-weight ratio. That is to say, the platform can be very heavy, but it is instrumental to the payload, to the instrument that we want to embark. And if we want to reach far, let's say, to explore the universe with actual propulsion or actual technologies, it means very heavy platforms. While if we consider such energy which is more sustainable, and if we work on kind of miniaturization, but miniaturization is a big game changer everywhere, to be honest, and including the nuclear energy, then we see the possibility to achieve that quicker. So then also, somebody mentioned mass production. It's also to increase the number of missions. If we have a low-cost approach, well, here I'm not sure it will be possible, but maybe you will say the contrary. I don't know, Hamid, if you have also an argument on the price of this kind of nuclear reactor. For us, it will help us to, let's say, to extend again the capabilities for exploration and for science. So the answer is yes, we can with the actual technology, but it takes more time because those technologies have limits. The absence of sun can be replaced by a lot of battery. We are talking about fuel cells, notably, but that's an issue nevertheless, because it means that it is detrimental to the mission itself, and it is also detrimental to the duration. That is to say, the guy who will develop the spacecraft maybe will never see the result of the spacecraft at the end. So what we want is at least a quicker end-to-end approach, and giving more opportunity to our, let's say, to our astronomers, to our human science community, for having increasing the endeavor at this level.
Thank you, Jamila. I was checking the wrong page on the application, so that's why I didn't say anything. So there are, let's say, many of them. I would propose to postpone them to the end of the session, but still somebody here wants to ask you, but this will be the last one.
Okay, yeah, thank you very much. My name is Ramon Wies. I'm from KTH, Stockholm, Sweden, and great joy to listen to all of these experts, really very nice. I just want to make a comment, a question, and an advertisement. The comment is, as mentioned, interaction with society, that nuclear still has, let's say, a kind of bad name. But isn't also that we have perceived much too little the benefits of radiation? As you mentioned, for example, medicine, that there is something in the communication which has always looked at the negative side and not at the positive side. I think that is the comment I would like to make. The question I want to pose is, we're looking at the European side, and of course we're quite good at creating a European framework for collaboration, but all the areas you mentioned is a huge activity outside Europe as well. How do we look at international cooperation? I mean, it's China, it's United States, but also in many countries there's hungry people who want to contribute. How do we open up Europe? I think that's a key issue for Europe to really promote and to be at the forefront about mass production, all these kind of issues out there, and we may not be able to solve it in Europe. And the advertisement is, I have a poster, is we have developed a cheap sensor system for measuring radon in groundwater. The project is called Artemis, and we're happy that Europe won't support it. We want to use it to improve earthquake forecasting, but it can, of course, be used in any way of monitoring radioactive leakage or whatever if you want to measure groundwater. It's highly sensitive, and the important is that it's cheap. Thank you.
I can start to answer because ESA, European Space Agency, has always had international cooperation. So far, you know the classical suspect, let's say, NASA, JAXA, India, ISRO, etc. Today, when I am in discussion with some of research centers in nuclear, they have already some partnership with, notably with the Japanese, because they are well advanced in this area. And there could be a way also to accelerate. And we don't close the door for that, of course. It's part of our DNA to do cooperation. It's just that the lessons learned that we had recently coming from the other side of the Atlantic has brought us to moving from what we call interdependency to more something that is really a cooperation, but not with a dependency. And I will develop that in the next step.
Yeah, maybe I add something. I mean, in the medical field, it's very obvious that we have collaborations all over the world, basically, and that's increasing. There's sometimes some tension with some countries, as you might also see, because people are trying to, let's say, rebuild stuff or things like that, if you talk about innovation. But in principle, there's really in the medical field, health is not stopping at one end. And we are having special even third missions for third world and things like that, so that there is a lot of things ongoing. And Europe is, at the moment, I'd say, kind of together with some others, in a very good shape in that, which is kind of bringing hope. I mean, we are really having strong industry here, but also our academic situation is getting better. And we have a lot of things, because we have approaches that are based on quality, that are based on innovation with quality and stuff like that. So that really helps a lot. And we are cooperating with many American institutions, including FDA, including many large universities. That's currently a bit difficult, as you know, but in principle, yeah, there's a lot of interesting cooperations.
May I add something? I think the problem is not in the scientific collaboration. Where we are lagging behind in Europe is getting what is developed in the labs, in the universities, in the research centra, to turn them into innovation and into technologies. Because our system is completely different, for instance, from the American one. In the United States, funded research by public money, all what you discover is open for valorization by whoever comes as industrial American one. And even if we do collaboration, Europeans, if they put $1 in your project, the outcome of that is also open for them, for the, the partners. It's very hard to get then this closing. Whereas the tendency here in Europe, we have all continuously worried about the IP valorization at the level of the research. Instead of offering that IP to as much as possible of our companies. And the companies also, they do not have all the time the reflex, maybe in some domains well, but in some others not. They do not go to grab the innovation, the research out of the institutions. And that's, I think, the big, from my point of view, difference between Japan, that I know, US, China, I don't know how it works, to tell you the truth. But this is something which maybe we have to think more at the level of the European Commission, and that there were attempts, but still we are not actually, we can give, if you are funded by the European Commission, the framework programs, you should be ready to open the outcome. But we don't have users to come to take that and make something out of it.
Yeah, in medicine it's definitely different.
Yeah, different.
So there we have that. We have, for example, the Innovative Health Initiative, which are programs just like that. You do it together with industry even. So that's, there I think we are on a good way there. So that's why I mentioned it there. But that's maybe specific.
I would like to keep time to move on what we had just prepared. So we have some specific questions that will be asked to you, and I would like that we have some enough time in order to go through them and to have some interaction about them. So, sorry.
Thank you, everyone. So now, as for specific questions, at first, let's touch at modularity and sustainability in new nuclear applications. The first speakers that we are asking to answer this question is Toby and Jamila. How are new developments in nuclear technologies, especially modularity and sustainability, shaping the future of floating nuclear power plants and space propulsion systems? And also, which countries are leading the charge in these areas?
Okay, thanks very much, Krislin. So it's kind of a two-part question. I think, if it's okay with you, I'll answer the last part first, because it kind of may set the scene a little bit better. So, which countries are leading the way, have led the way? If we look back to the 60s and 70s, there were some experimental commercial nuclear ships. The most famous one probably came out of Eisenhower's Atoms for Peace. That was the US Savannah in the United States. There was also a German ship called the Otto Hahn and a Japanese ship called the Mutsu. And they had varying degrees of success, but ultimately, with the oil price crash and cheap energy, they were never going to survive. But let's acknowledge a simple fact. Russia is the only country in the world today that operates a commercial nuclear fleet. They have one floating nuclear power plant in operation. They have quite a large fleet of icebreakers, and they're building more, both for their own domestic use and with an eye on the export market as well. China is understood to be developing a solution. We're not quite sure how close they are to deployment. And there are sort of other projects coming in from other countries as well. Now, looking back across to the OECD, most of the development in this area for advanced maritime appropriate reactor development is taking place in the States, but also in the EU to an extent as well, especially France, and to a lesser extent perhaps in the Nordics. But the reason why I start with geography first is because there is a misconception developing, I think, that nuclear and maritime will suddenly become everywhere all at once. And I don't agree that that's going to be the case. I think it will exist in quite tightly bounded in certain sort of close ecosystems and jurisdictions. And you need to have a very strong jurisdictional spine running through this. It's the country of the reactor developer, the country of the duty holder that operates that asset, the flag state of the vessel that asset sits in, and of course the country that owns the nuclear fuel as well. All of those need to match up. And when you put a global map of strong maritime regulators and strong nuclear regulators, you transpose them on top of each other, there really aren't that many. So that sort of leads on to the earlier part of the question, I think, because you're going to have these sort of relatively local deployments, regional deployments, and some of the first assets, I think, in this sector will be quite small. So it takes me back to this concept of building in shipyards. Building the entire power plant in a shipyard is a new benchmark for modularity. To an extent, nuclear power plants, terrestrial nuclear power plants today, elements of them are already modular. The pressure vessel, the key parts of the nuclear island, the Fabergé egg that sits inside this enormous civil construction project is already modular. It's the 80% of the cost, and the 4 million tons of nuclear-grade concrete that we've poured is not the modular part, and that's where the problems have crept in. So by building centrally, using a centralized workforce, as I've mentioned, we can drive down those costs, speed up those deployment times, and of course, you benefit then from the flexibility of having flexibility through operation with a mobile unit, and then obviously faster decommissioning as well. And then the final point I'd make is developments in sustainability. I mean, again, we touched on this earlier, but by using advanced reactors with long or ultra-long fuel cycles means we never have to handle fresh or spent nuclear fuel in ports around the world. That's what the public will want to see, and that's what safeguards rules will expect. And I think in certain types of advanced reactors, we can use those fuels so efficiently that we may be able to even fission more than 90% of the fuel and certain actinides, leaving us with a very, very small final waste footprint. If you take, just to leave you with an example, if you take the example of a large container ship burning heavy fuel oil as it does today, that ship will emit between 4 and 5 million tons of CO2 during its lifetime, approximately. You change that to a fast spectrum molten salt reactor, you've got to 30 years of zero emission operation, and you have a final waste footprint of a very highly radioactive piece of metal about the size of a domestic fridge freezer. So it's an absolute paradigm shift in terms of sustainability. That's why I think nuclear maritime is so exciting. But I'll leave it there. Thank you.
Again, I would like to ask the technician if he can project again the same slide as before. I will start with the country indeed. Today we are completely, let's say Russia and US are the leader in terms of reactors production in fission, in particular Russia, who is the leader for the small reactors notably, and both of them are pushing for a microreactor. So I read recently that the US is going to give to 8 contractors, potential contractors, the possibility to develop a microreactor. And there is a company named Westinghouse who is well positioned with their EVNC for the microreactor. That's the reason why it is fundamental that we in Europe, and when I say Europe is ESA member states, so I include UK, if I may, we need to push as well to stay in the competitiveness, but to stay also not to be behind, to be honest. And it's really important also because we have the advantage that space on top of maritime, on top of other application, medicine, and we are talking now more and more about the need of big power, big energy for data center and for artificial intelligence. So we need to be enabling, to be the enabler for having such microreactor all together, join our effort to have European microreactor. For me, I'm passing this message and to ask your help, because it's super expensive to develop, but it's also based on your background to help us to come to such technology in an acceptable development, let's say, time, a life cycle time. And I should add that if we compare in terms of need of power, we, in space, we are not so demanding. I didn't mention, it's true, the RHU and the RTG. RHU, we are dependent on the US. RTG, I think it's mainly the Russians who are still producing a lot of RTG, radioisotope thermoelectric. I'm not sure that US is producing that much today. They are more focusing on RHU, and we are really dependent on them. I can confirm that we were in discussion to embark one of their RHU in 2 missions, ExoMars and Argonaut. And the nice Trump is helping us to develop our own RHU, so I should thank him a lot. Because now that he has put, I don't know if you heard the announcement, but he said we are going to cut the budget of the NASA. So NASA is the equivalent of ESA. And by cutting the budget, he's impacting the possibility that NASA deliver to us some RHU. So that's the reason why we have our own program. The name is Endure. It's not a title made It's a title made on purpose. And we need really to develop the RSU for our use, starting from ExoMars, because we have a mission to Mars before the late 20s, before 2030, and Argonaut for a lunar lander to the moon. So this first step is very, very important for us. This is this one, as I mentioned, it's low power, but it remains very interesting. However, as I have a lot of stakeholders surrounding me, I am concentrating myself, because I'm more turned to the future than the short term, let's say. It's very important to pave the way to the macro reactor so that I can push the propulsion, nuclear electric propulsion, but also nuclear thermal, and also the surface habitat, as you can see. And we are more or less in the same range as maritime and classical reactors. So here, we need to exchange a lot to capitalize from your background as a maximum. And if I should say that, of course, to answer to your question about we want more sustainability as well. Space is pushing the limit, but we need a modular approach. I already mentioned it. We need it compact to be able to be transported on space transportation side, and compatible with the possibility to do assembly integration in space automatically. We need automated systems, so the robots are essential to be developed in parallel to be able to ensure that mission of assembly and integration. And we have also a strong reflection, and we would like to develop this reflection with you on how to make it also inside a circular economy. As an example, I already shared with some colleagues, I mentioned before reaching the surface of a planet, we need to fly first to travel. And the macro reactor that will be used once the propulsion has done his job and we land on the surface, why not then transfer the macro reactor used for the transfer to the surface? This is circular economy, so the question will be how is it possible to do it? Is there any technical locks that we need to unlock, and what are the breakthroughs to reach there? So this is essential on the circular economy. And last but not least, it was my word just before, we need really to accelerate the European non-dependency. We are capable, we have the brain, we have the hands, we have the resources. I think we have everything of the recipe to make it, to put the ingredient in the cake and to make it. So it was my last word. I need you, I need all of you to help me to make it happen. Thank you.
Thank you very much. Now we will move to Arnie and Christophe on a more general question related to waste, and what lessons from nuclear waste and material management could be or have been applied to the other industries tackling long-term environmental challenges. What are the most exciting cross-sectoral innovations in medical nuclear field that could inform or improve the well-being of the population? So Arnie and Christophe, now it's for you.
Thank you for the question. I take the first question and I leave the second to Christophe. I think that would be good. And sorry for being a little bit boring, but I think it's important to focus on the full life cycle because that it's so easy to rush away. We see new possibilities for the future, but we need to see that we can manage the full life cycle, and coming back to this with circular economy and those things. What I think we could be proud of within the nuclear industry, I wouldn't say lessons learned, even if it's lessons learned, but it's good habits. And that is that today we are working with the full life cycle planning, including requirements on competence management and recording. There are so many examples from other industries that there is no memory left and it's a big mess to sort out. I think we have a lot to share to others. Also that today the requirements we have when it have that we should have preliminary end-of-life plans for nuclear facilities. That's also something that is good, because the major impact of the end-of-life is set during the design stage. Then you can influence that. And if we would like to be circular in the future, we need to put more efforts into the design phase. Another thing which I think also is good to share with other industries is the strong funding mechanism which has been developed within the nuclear industry. Because it's too often you hear about companies going bankrupt, there are no records, there are no money, just a big mess. But taking benefit of what has been developed within the nuclear sector, I think that would be beneficial also for other industries. And that also includes the responsibility by the operator to manage what has been generated in terms of end-of-life aspects. It cannot be just shipped to somebody else. You are responsible and you need to manage it. And not at least, and that also relates, I would say, to new technologies, that the good habit related to mechanisms to avoid future orphan waste. Because it's so easy to see possibilities. This could be a fantastic product, but what next? Maybe 30, 50 years later, how to manage this? Because we have too much legacy around which we have not thought through from the start. Thank you.
Yeah, thank you, Ani. I think I can just jump up on that because, you know, we talked already a lot about innovation in the medical field and that this is also strongly related to application of ionizing radiation and the radiation protection related to it and things like that. We have some issues even there, and there we should learn from the other fields. I think this is something really important. For example, we had a large discussion, and it's still not ended, which kind of stops innovation in some points. I mean, we are trying to overcome it right now. I will give you the example. This is currently there's new radio tracers that are supposed to be on the market for curing prostate cancer. So not to leave the women out, this will also have slightly different cancer tracers that can be used for breast cancer. The radio isotope used on that is lutetium. And in all European countries, for example, there are different rules on how to store the waste that is obviously excreted, which leads even to the point that it is different in different countries how long patients have to stay in a hospital. So in Belgium it's 1 day, in Germany it's 2 days, in Great Britain it's no staying at all. No one knows how to deal with the waste, actually, right? And so we have large storage capacities, and I don't know if you heard the lady from the Polish waste disposal site. She said, yeah, at the moment we are basically storing waste from medical applications. So this is a large issue, obviously, and we are far from having a circular way to deal with that. I mean, we have both short-lived and long-lived radioisotope, and we need to find ways how to deal with that in terms of innovation, in terms to allow industry to put things really forward. And there are some things where we need to find better ways, and we have to learn on how to do that and how to work into circular strategies as well for these cycles. And I hope, Michael, you will agree on that.
Thank you. Now, let's move on to our last specific question, which touches on the supply of nuclear materials and services across different sectors. This question is for Hamid and Mikael. What are the key recommendations for the security of supply for nuclear materials and services, and could these approaches be applied to other sectors as well?
jump or I connect to what has been said before about for instance, the people making research for medicine and for their trials, they are not needing huge quantities, but many labs need a small quantity. And if they go to buy that, some labs, they can't afford to pay the price, even it's small money, but some labs, they can't do it. And then comes on the top of that after what you do with your storage. So I think for me, there is, when I came back to my idea to say, there should be, for this kind of activities, a sort of bank installed at the level of Europe with facilities that are producing for this activity. For instance, in my MIRA project, we foresee an isol facility which is capable to deliver those kind of medical isotopes, and we are working with our government and with the European Commission to see that it should not be against money. Because when you go to the companies that are willing already to sell the lutetium for, let's say, becoming rich, they can't give the quantities which is needed for the research. And this is sometimes a big, let's say, the chicken and the egg. We need to make the research that should be affordable, so we have to guarantee those kind of things. Security of supply, and also for other application, if I take the space, the quantities that we will need for the beginning of demonstration, we should be securing that for the research. And secondly, for me, among the materials that are for sure strategic for the security of supply and for the independence of our continent, of the European Union or the Europe, for me, guaranteeing, and Mikhail can certainly say more about this, the capabilities of enriching, for instance, uranium. Today, it's an issue if we are not capable to guarantee that for sure that we have it in our continent. And second thing, for some specific material, when I say we have to go to this advanced reprocessing, etc., there also we have maybe tons of materials, but they are embedded in the spent fuel. And then this is then a source from where we can pour all those strategic materials. But now we look to them as waste. And so that's maybe things that we have to think about to guarantee supply of strategic materials and not looking to that just from one small angle of I would like to transmute or whatever. So maybe things that we would like to destroy by transmutation are very valid for medical applications or for space applications, etc. So then we have to open more holistically the use of those materials, and that's what this session is meant for. And I think that what we have really, there are possibilities, but up till now, everyone working in his corner with his objective alone, we miss the chance. And so that will be certainly a way to advance. Mikhail.
Mikhail?
There's lots of things I would want to say, so let me try in my head to sort them a little bit. Maybe I could have the presentation, the 2 slides I had prepared here on the security of supply recommendations. But before that comes up, just 1 minute on the medical. I mean, I agree that there is an issue on the availability of the isotopes. I think there is a European project, PRISMAP, which is doing an enormously important work to support researchers and also sort of people involved in medical research, medical application, to have these available. But there's another line here. I mean, there's the line, Christoph, and you know what I'm going to say, where the sort of medical research ends and the commercial use begins. And the commercial use is a problem if the production capacity for one stable isotope is completely bought up by one pharmaceutical company, and that blocks not only research, but it also blocks access of patients to treatment and so on, which is very, very difficult. But the question is on security of supply recommendations. Could I have these slides, please? Maybe. Well, if not, okay. The supply agency, as I said earlier, we are making, at a yearly basis, we're making recommendations to utilities, essentially, for principles of securing supply chains. And these are built, and I mean, maybe the slides will come up, but otherwise they will be available, and they're available in the annual report I had. No, the other one. The other presentation. Let's see if it's... All right. We don't have time for that now. So they are built around diversification of supply sources. They are built around long-term supply contracts. They're built around that being based on a proper risk assessment, and they're being built really on sort of foresight in terms of your supply needs. So I'm now being very, very quick, which makes these recommendations sound like motherhood and apple pie, but of course there's a lot of specificity for the nuclear sector behind that. I would recommend you have a look at the supply agency's report. Whether they're transferable to an extent, because of course nuclear supply is a special area. It's an area which has always been governed by regulation, including safeguards in certain areas, so it is not transferable to any other, if you take uranium and processed uranium, critical raw material, but it is an area where we have managed, I think, over the years to have a reasonably secure supply chain, which now is being looked at again in terms of the geopolitical situation, but it is maybe something which other areas look into, and I know within the European institutions, when there is a discussion on a strategy on critical raw materials, people are also looking at the nuclear supply chain. So, Christoph, just to be very, very, very quick on that. And there are a couple of slides which should be on your app, which give at least the headlines of these recommendations.
Thank you very much. Unfortunately, time is really, let's say, the deadline for us. Thank you for your contribution and so on. There are still time for, I guess, a few questions. Actually, we won't have time to go through all of them. Sorry for that. So it will be my responsibility to sort out and to pick up some of them. One that I find perhaps of some cross-cutting issue is now we know that globally there is a huge effort in defense to support EU defense. Do you see that in this effort there are some opportunities either for nuclear or for other types of application that this, let's say, increasing momentum in budget and in effort could somehow have some cross-sectoral activities for your own field of activities as well? Perhaps it will be easier, I guess, for space. Unfortunately, it looks like straightforward, but I mean also for the other types of domains as well.
Yeah, I mean, we definitely see some dual-use technology potentially in the maritime nuclear space. I know the United States are looking closely at the concept of forward operating bases being powered by resilient mobile power sources that you can only really deliver by sea. They have already had one floating nuclear power plant operating in the Panama Canal in the 60s, so it's a proven kind of concept. yeah, it is that grey area between commercial and defence that we always have to be very careful of. Of course, nuclear in the maritime sector is currently an export-controlled item. It's under the munitions list in ITAR, so there needs to be a separation between that and the commercial space before things can develop. But there are sort of programs underway to slowly disentangle that and to start that. But yes, I definitely see that there will be dual-use technology potential there.
Maybe just very brief. So, I mean, in the US, the US Army has for a long time been the strongest funding agency for optimizing radiation medicine, actually. And so that was on ionizing radiation-based imaging, radiology, and nuclear medicine, especially. But there's also a topic on radiation medicine where you deal with on how to cover diseases caused by ionizing radiation, accidents, but also maybe nuclear threats or something like that. But how to implement that into some resources is not clear at the moment. So I don't know what will happen in Europe in respect to that.
I guess the quick question would be who will take care of that, because there is some kind of impulse given to the defense sector. But in terms of, I don't know, DGs or whatsoever, perhaps there should be some kind of communication in the goals and so on. But I don't know if this is currently foreseen or not, but it could be some kind of a good question, I don't know.
I think there is also something which is our life we were trained for peaceful applications, you see? And that's the first word that whenever you say nuclear, you say peaceful applications. And those questions that are now coming directly or indirectly is very, I would say, disturbing for the majority of the people working in this field to say, can your applications or your research serve in case of? And it's, for a lot of our researchers and scientists, a big, let's say, moral question. And that you can find applications of your research that could be serving even for in defensive approach against the problem. Yes, there are. But I think the main question today, will you use that opportunity just to make funding your project, which was initially foreseen for peaceful application? You can see the drama for the people, actually. This is really a real question.
I know also by experience in terms of law, there is this dual-use nature of the activities. I know by experience in my own field, which are, simply, let's say, working on codes and methods. It's always a question of export control, because this dual-use constraint used to everything is talking about nuclear, unfortunately, turns into this type of consideration. So, okay, there are still room for improvement, if I can say so, if we try to move together.
So, I would like to complement, space is also dual use and space is also for peaceful application. The way we proceed when we implement an activity so far, I say it so far because there are some change occurring currently, was that we leave to the companies to do their own commercialization. And by commercialization, we also, without saying it, we let them because the property right of anything developed with FISA belongs to the company. Of course, we have some point in our contract related to export control, because we want also to have a license to use those technology. But if the company or the institute or whoever wants to develop for defense and use the technology they develop with us, it's totally open. Moreover, of course, we launch some spacecraft that are for defense, but it's launched under, let's say, a commercial relationship between the entity of defense and the commercial company. So we have always been like that, respecting our DNA of serving peaceful application. Then step by step, we have extend the perimeter to peaceful and security. Security meaning for the safety of our people. So of course, we are now doing a little bit of defense, but in the sense protection of the people, the life of the people. So it's more security, it's not weapon, it's not sending a weapon elsewhere, it's having a kind of protection. So that's the way we develop some a lot of spacecraft for security. And now we are in discussion to extend again. So there are a lot of discussion between RDG and some national military entities, so Minister of Defense from the different ESA member states, to extend now the perimeter and to officially say we are going also to develop technology that serve the defense. We are not saying we are going to develop weapons, but for instance, one of the technology in my basket is hypersonic vehicle. Fantastic, this hypersonic vehicle for me is perfect for very low orbit to have a reusable vehicle. But we know all that hypersonic vehicle is also another use. And certainly for mass production, I suspect that it will be more used elsewhere than for space application. But we are ready to develop hypersonic vehicle, ramjet, whatever is related to this kind of application. And officially, this kind of application are for defense more than for space. Voilà. But there are discussions ongoing, so be ready, listen to the, turn your headset or your newspaper to November, third week of November this year, because there will be a lot of announcements, I think. Could be we go to do defense or we don't go at all. Maybe the Ministry of Defense will tell us no, but decision will be taken at the what we call the Conference of Ministers of ESA, planned somewhere on the 20th of November 2025. But definitely nuclear is already in, because nuclear is for peaceful application.
Okay, thank you very much. So you have noticed the background turned red, so it's an invitation to close the session. So I would like to thank the panelists for being here and the commitment they had in preparing and being here. So thank you very much again. Thank you for being here also as well. And so, okay, so I'm closing here the session.
Yeah, I'm open for any question besides during the lunch break, if you have any, because we could not answer now in this plenary, but and I think my colleague as well. So don't hesitate to reach out if you want. Thank you very much to all of you.
And sorry, Michael, to have cut the grass be on your feet. But the presentation will be made available on the site as well. So if there are any questions related to that, the panelists are there and they will be happy to, let's say, give you the answers. Now we have, Frederica has also prepared a summary. So I don't know if you have time to share a few words about this, or just, it will be later on. Okay, it will be given later on in the closing session. Okay. Thank you again, and that's it.